600,000 vehicles. That's how many GM trucks and SUVs were recalled in April 2025 because their V8 engines could fail without any warning. No check engine light, no knock, no hesitation, just silence, and then nothing. But here's what makes this story different from every other recall you've heard about. GM issued the fix. Owners went to the dealership. They did everything right. And the engines kept failing anyway. Because by January 2026, NHTSA had already opened a brand new federal investigation, not into the original problem, but into whether GM's own recall fix actually worked at all. Welcome to the modern engine crisis. And trust me, GM is just where it starts. For decades, buying a Toyota, a Honda, or a GM truck meant one thing above everything else. The engine would outlast the rest of the vehicle. 200,000 miles was normal. 300,000 wasn't even impressive. These were machines built to be forgotten. You just drove them, and they kept going. So what changed? Because right now, brand new Toyota Tundras are seizing before 40,000 miles. GM's 6.2-liter V8 has racked up over 28,000 documented failure reports, with roughly half of those happening while the vehicle was moving on the road. And Honda is staring down an active federal investigation covering over 1.4 million vehicles for defects that have already triggered a class action lawsuit. This is not a handful of horror stories. This is a pattern, and once you understand what's driving it, you'll never look at a new car the same way again. To understand why modern engines are breaking, you first have to understand why the old ones didn't. Take a truck engine from the early 1990s. Big, naturally aspirated V8. Thick cast iron components. Tolerances measured in thousandths of an inch. Heavy 10W30 oil that coated every surface with a generous protective film. And here's a detail almost nobody talks about. Those old bearings had a thin layer of lead on the surface. If a microscopic piece of debris hit that bearing, it just embedded harmlessly into the soft lead. If oil pressure dropped for a split second on a cold start, the lead absorbed it. Those engines had multiple layers of forgiveness built into them. You could skip an oil change, run them hard in summer heat, tow more than you should, and they just kept going. Now look at a modern engine, turbocharged, downsized, running cylinder pressures over 2,000 psi, the kind of pressure once reserved for race motors that get torn down after every event. Tolerances measured in microns, smaller than a human hair. Ultra-thin oil that provides the thinnest possible protective film. Hard aluminum bearings with zero ability to absorb debris or forgive a momentary pressure drop. Modern engines are engineered closer to the edge than at any point in history. And when you remove every layer of forgiveness from a system that has to work perfectly across hundreds of thousands of operating cycles, small problems become catastrophic ones. Now let's talk about what's actually happening right now, brand by brand. Starting with GM, because the timeline here is damning. GM internally opened and closed 3 separate investigations into 6.2-liter V8 failures in February 2022, June 2023, and July 2024, and took no action any of those times. It wasn't until NHTSA launched its own investigation in January 2025, after roughly 350 consumer complaints reached its agency, that GM finally moved. The recall came in April 2025, covering nearly 600,000 trucks and SUVs, the Silverado 1500, Sierra 1500, Tahoe, Suburban, Yukon, and Cadillac Escalade from 2021 through 2024. The technical problem involves 2 things happening at once. First, machining debris, microscopic metal particles left behind during manufacturing, circulating through the oil system and grinding into the connecting rod bearings. Second, crankshaft journals produced outside of specification, with surface finishes rough enough to act like sandpaper against the bearing metal. GM's official fix had 2 parts. If your engine passed a dealership inspection, you got thicker 0W-40 oil instead of the factory 0W20, a new filter, a new oil cap, and a 10-year, 150,000-mile extended warranty. If your engine failed inspection, it got replaced entirely. Sounds like a fix, right? Here's the problem. By January 2026, NHDA had received 36 separate complaints from owners whose engines catastrophically failed after the recall work was already completed. In every single one of those 36 cases, the vehicle had already been through the official fix. NHTSA has now opened a formal investigation specifically into whether GM's remedy actually resolved anything, or whether hundreds of thousands of engines are still at risk. And as of this month, GM is actually trying to get the class action lawsuit dismissed, arguing the failure rate is only around 3%. And NHTSA isn't buying it. Their position is that the fix has failed, both the oil change approach and in some cases the replacement engines themselves. One GMC Yukon Denali owner summed it up perfectly. His engine died at 37,000 miles, just 3,000 miles after the recall work was done. That's where GM stands today. Now let's talk about Toyota, because this is the one that should genuinely alarm you. Toyota's entire value proposition is built on reliability. People pay a $10,000 to $15,000 premium for a Tundra over a comparable Silverado specifically because of what the Toyota name is supposed to mean. So when Toyota's new twin-turbo V6 started failing, it hit differently. The affected engines are in the 2022 through 2024 Tundra, the 2023 and 2024 Sequoia, the 2022 through 2024 Lexus LX 600, the 2024 and 2025 Lexus GX 550, and the 2018 through 2022 Lexus LS 500. And what owners and engineers started calling the invisible killer is exactly that. No warning lights, no codes. The engine runs completely normally right up until the moment it seizes. Toyota's official explanation pointed to machining debris left during manufacturing at their Alabama and Hatahara plants, contaminating the main bearings. But here's what makes that explanation hard to accept. Independent teardowns of failed engines show the main bearings completely destroyed, scored, heat burned, seized, while the rod bearings, which share the exact same oil circuit, show almost no wear at all. If debris were randomly circulating through the oil system, you'd expect to see damage across everything oil touches. That's not what the teardowns show. When only one specific bearing position fails, while everything else on the same circuit is fine, that points to a design issue, a pressure distribution problem, a bearing clearance too tight for the thermal load of a downsized twin-turbocharged configuration. The tell? Toyota quietly redesigned the main bearing in later production runs. You don't redesign a bearing to fix debris contamination. You redesign it because the original bearing couldn't handle the load. And just 3 weeks ago, May 2026, Toyota issued yet another recall, covering an additional 43,000 vehicles, expanding on 2 previous recalls from May 2024 and November 2025. Owners have now filed a class action lawsuit, arguing the initial recall was insufficient. And based on the pattern, they have a point. Now Honda, and the scale of what's happening here is bigger than most people realize. Honda is facing a federal investigation covering more than 1.4 million vehicles. The 2016 to 2020 Pilot, the 2018 to 2020 Odyssey, the 2017 to 2019 Ridgeline, the 2016 to 2020 Acura MDX, and the 2018 to 2020 Acura TLX. Minivans, family SUVs, 3-row people movers, vehicles bought specifically because Honda's reputation for reliability was considered bulletproof. What's happening here is actually more specific than contamination, and I think it deserves more attention than it's getting. The equipment used to grind the crankshaft pins was improperly calibrated, producing a pin with a slight convex shape. what engineers call a crown. Instead of the connecting rod bearing sitting flat against the pin and distributing load evenly across its surface, all of that force concentrates at the center contact point. Think about pressing your palm flat against a table versus pressing with a single knuckle. Same force, completely different pressure at the point of contact. That concentrated pressure exceeds the thermal limits of the bearing material. The oil film breaks down locally. The bearing deteriorates silently. No warning, no noise, until the engine takes itself apart, sometimes at highway speed. The original recall covered 250,000 vehicles. The current investigation covers 1.4 million across 5 model years. That kind of expansion doesn't suggest a one-time calibration error. It suggests this geometry problem was present across a significant portion of Honda's V6 production for nearly half a decade. A class action lawsuit has already been filed, and Honda's powertrain warranty only covers 5 years or 60,000 miles, meaning many of the owners whose engines failed were already outside coverage when it happened. So we've got GM, Toyota, and Honda, 3 of the most trusted names in the industry, all facing simultaneous engine crises with the same underlying fingerprint. That's not a coincidence. Here's what I think is actually driving all of this. CAF standards. Corporate average fuel economy regulations set the average MPG that a manufacturer's entire fleet must achieve or face massive fines. We're talking $17 per vehicle. For every tenth of a mile per gallon, they fall short. Miss the target by just 1 mpg across 2 million vehicles, and you're looking at over $300 million in penalties. So manufacturers squeezed every fraction of efficiency out of every engine by any means necessary. Tiny turbocharged engines instead of larger naturally aspirated ones. Oil thinned from 5W30 down to 00W20, 0W16, and in some current applications, 0W8. Fluid so thin it would feel almost like water in your hand. Cylinder deactivation, stop-start systems, direct injection. Most of the technologies exist primarily to hit a number on a government test cycle. Not because they make engines last 200,000 miles. Old engines could survive contamination, a missed oil change, a cold start in January. The tolerances were loose enough, the parts beefy enough, the oil thick enough that the system had built-in forgiveness. Modern engines cannot survive any of that. You've built a machine where everything has to go right, every time, across millions of operating cycles. At mass production scale, that's simply not achievable. And here's the part that should make you genuinely angry. The manufacturers ran the math. A predictable rate of engine failures, warranty claims, and recall settlements was calculated to be less expensive than missing CAF targets. They made a business decision about your engine's lifespan. You're the one paying for it. Sometimes $15,000 to $20,000 for an engine replacement on an $80,000 truck before it hits 50,000 miles. And when an owner fights back hard enough to trigger a lemon law claim, manufacturers have been quietly structuring buybacks as customer satisfaction transactions instead of formal lemon law resolutions, which means the title branding that would warn future buyers doesn't always apply. That vehicle gets... First, go to nhts.gov right now and check your VIN. If you're inside an open recall, book the repair immediately. Most of these failures come without any warning whatsoever. Second, ignore the 7,500 to 10,000 mile oil change intervals in your manual. Those numbers are a cost of ownership marketing figure, not an engineering recommendation for turbocharged direct injection engines. Change your oil every 5,000 miles, regardless of what the sticker says. Third, if your vehicle has stop-start technology, disable it every single time you drive. Every cold restart is a brief moment of near-zero oil pressure on micron-level bearings. A $50 to $100 OBD2 device can disable it permanently. Fourth, if you have a direct injection engine, get your intake valves cleaned professionally every 30,000 to 40,000 miles. Carbon deposits don't trigger warning lights, but they restrict airflow and accelerate the exact combustion conditions that destroy these bearings. Walnut shell blasting is the only method that actually works. Fifth, after your warranty expires, consider stepping up one viscosity grade. If GM is now running recalled 6.2-liter engines on 0W40, running 530 in place of 0W20 in your own engine isn't extreme. It's giving your bearings a fighting chance. And sixth, if you're shopping used right now, treat any 2021 through 2024 turbocharged engine from any of these brands with real caution. A 2016 to 2019 naturally aspirated V8 with honest highway miles may genuinely be the more reliable purchase for 2026. The scary part is, this may only be the beginning. Emissions regulations keep tightening, engines keep getting more complex, and the margin for reliability keeps shrinking. That's why some of the most trusted engines in American automotive history are suddenly failing faster than anyone expected. Now I want to hear from you. Do you own one of these affected vehicles? Have you been through the recall process? And do you actually trust these turbocharged engines long term? Drop your experience in the comments below. If this video opened your eyes to something you didn't know before, subscribe to Car Blueprint, because we've got a lot more deep dives like this coming. See you in the next one.